take a look now at the cube root function. So the one that looks like this, the cube root of x. So again, this one's going to be our parent function. So let's start off by making a table of values. Let's start by putting in 0. The cube root of 0 is 0. Let's try the next number, 1. The cube root of 1 is 1 because 1 times 1 times 1 is 1. Now I'm going to be picky about the next number I choose. I don't want to choose 2 because that would give me a decimal. I don't want to choose 4. That would give me a decimal. The next number I'm going to choose is the number 8. Because the cube root of 8 is 2. So I'm going to go over 8 and up 2. The next number I would try would be 27 because the cube root of 27 is 3. But I'm going to stop there. Let's think about what happens on the other side. Can you have the cube root of negative 1? Is there some number that you can multiply times itself 3 times to give you negative 1? Yeah, negative 1 times negative 1 times negative 1 is negative 1. So you can have a cube root of a negative number. So the cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. So the cube root graph looks something like this. This time the domain, the very smallest x value you can have is negative infinity, and the very biggest x value you can have is positive infinity. Same thing happens with the range. It never stops and never stops, so it goes negative infinity to infinity as well. So there's the cube root function. Let's go down to this first graph here, and I'm going to graph two different things. I'm going to graph f of x equals negative cube root x, and then with the other color, I'm going to graph f of x equals cube root of negative x. So let's think about what we know about square roots. If there is a negative on the outside, that's going to take our y value and flip it. So up here on the parent function, we went input 1, output cube root of 1, output or input 8, output cube root of 8. But this time, it's going to be flipped across the x-axis. So for the negative cube root of x, instead of 1, 1, it's going to be 1, negative 1. Instead of 8, 2, it's going to be 8, negative 2. So you can see how this time it has flipped over the x-axis. So there's negative cube root of x. The parent function looked like this. Okay, let's think about what happened this time, and this is kind of interesting to see. If we put a negative on the inside, remember negative takes everything and reflects it across the y-axis. So this time this would be reflected over here, and this would be reflected over here. So these actually look the same for a cube root function. Let's do another one. Let's do the cube root of x add 2. Well, let's remember where the cube root of x looks like. It looks like this, where it goes through 1, 1, 8, 2, negative 1, negative 1, negative 8, negative 2. But this time it's going to be shifted 2 units up. So instead of 0, 0, it's going to be at 0, 2. Instead of 1, 1, it's going to be 1, 1 plus 2, which is 3. Instead of 8, 2, it's going to be 8, 2 plus 2, which is 4. So this one just takes every single point and shifts it up 2 units. Let's do one more of these. Let's do 3 cube root of x. Let's shift it as well like this. Okay, so I'm going to start by graphing the parent function. It goes like this. And then we're going to shift it. So here's the parent function. The first thing I'm going to do is I'm going to look at this shift. What does the -1 inside the parenthesis do? That shifts it left or right. So since it's a -1, it's going to shift everything to the right 1 unit. I didn't have this drawn very good. should have kind of gone through more like that. So everything's going to be shifted to the right 1 unit. So now if I drew the parent function, it would be over 1 up 1, over 8 up 2. But this time it's going to be stretched as well. So instead of over 1 up 1, it's going to be over 1 up 1 times 3. And instead of over 8 up 2, it's going to be 2 times 3, which is up here at 6. So this one is going to stretch and shift 1 unit right. And I think you'll see some good discovery on this in your Delta Math assignment. Notice on the cube root function, the domain is always negative infinity to infinity, and the range is always negative infinity to infinity because there's never a starting and a stopping point.